In this video, we're going to learn how to solve exponential equations with different bases. First of all, we want to solve this equation 3 to the power of x plus 1 equals 9 to the power of x. Now, the key to solving this equation is to express each side of the equation as the same base raised to some power. 9 can be expressed as a power of 3, so why don't we go ahead and do that. So we'll have 3 to the power of x plus 1, and then 9 is 3 squared, so write it like that, 3 squared to the power of x. Now let's go ahead and simplify using our exponent rules. So we still have 3 to the x plus 1 on the left-hand side, and then on the right-hand side, an exponentiated expression raised to another exponent, you multiply the exponents. So this becomes 3 to the 2 times x, so 3 to the 2x. Now, since 3 to the x plus 1 and 3 to the 2x have the same base of 3, their exponents have to be equal. So x plus 1 has to equal 2x. And now that's a pretty simple equation to solve. We just subtract x from both sides and get 1 is equal to x. And there we go. There's our solution. Let's try that again on the next problem. We want to solve 4 to the 2a is equal to 32 to the a minus 5. So look at 4 and 32. We want to express those numbers as exponents of the same base. And hey, they're both powers of 2. 4 is 2 squared, so write it like that. 2 squared to the 2a is equal to 32 is just 2 to the 5th. So 2 to the 5th to the a minus 5. Now we go ahead and simplify using our exponent rules. We just have to multiply the exponents here, so this becomes 2 to the 2 times 2a, so 2 to the 4a, is equal to 2 to the 5 times a minus 5. So just write that as 2 to the 5 times a minus 5. And now, since the bases are the same, 2 and 2, we can set the exponents equal. So 4a is equal to 5 times a minus 5. Write that down. 4a equals 5 times a minus 5, and now we just solve for a. So 4a equals, distribute the 5 to get 5a minus 25, then subtract 5a from both sides to get negative a is equal to negative 25, and then multiply by negative 1 to get a equals 25. So there we have it, a equals 25. Here are some more problems. We'll start with the one on the left. Solve 3 to the power of 1 minus x equals 2 to the 2x. What we've been doing before is we've been looking at the 3 and the 2 here and seeing if we can write them in terms of a common base. But 3 and 2 aren't exponents of a common base, unfortunately. So what do we do now? Well, what we can do is we can apply logarithm to both sides, and that'll bring those exponents down. So we'll write logarithm of 3 to the 1 minus x is equal to logarithm of 2 to the 2x. And now we can go ahead and apply our logarithm rules. We know that the logarithm of an exponentiated expression, we can go ahead and bring out that exponent in front of the log, so it's multiplying the log. So 1 minus x log 3 is equal to 2x log 2. And now we just need to go ahead and solve for x. So let's distribute this log 3. We'll just get 1 times log 3 is log 3, and then minus x times log 3. That's equal to 2x log 2. Then let's get our x's on the same side. So we'll add x log 3 to both sides to cancel it out from this left-hand side here. So get log 3 is equal to 2x log 2 plus x log 3. Now on this right-hand side, we have an x in both of these expressions, so we can factor it out. So we get log 3 is equal to x times 2 log 2 plus log 3. And then we just divide by that expression that's multiplying the x to get x alone. So dividing, we get log 3 over that expression, over that 2 log 2 plus log 3, that's equal to x. And there we go. There is our exact solution. We can also punch this into our calculator to get an approximate solution. And when we do that, we get x is approximately 0.442. Alright, on to the next problem. Solve e to the 3x plus 2 is equal to 7 times a half to the x over 3. So let's go ahead and use logarithms here, and moreover, because we see an e, let's use the natural logarithm so that things simplify a little bit. So we'll take natural log of both sides. Natural log of e to the 3x plus 2 is equal to natural log of 7 times a half to the x over 3. Now we simplify a bit. Actually, before we bring the exponents out in front of the logs, let's go ahead and simplify this right-hand side. This is 7 times this exponentiated expression, and we need to get this exponentiated expression, a half to the x over 3, we need to get that into its own log before we pull down the exponent. So let's use our log rule that converts multiplication inside logs into addition between logs. So this right-hand side will become natural log of 7, then plus natural log of a half to the x over 3. And the right-hand side will keep the same for now, natural log of e to the 3x plus 2. Now we'll go ahead and do that thing where we bring down the exponents. So this will become 3x plus 2 times natural log of e is equal to natural log of 7 plus x over 3 times natural log of a half. And we can simplify a bit. Natural log of e is just 1. So 3x plus 2 is equal to natural log of 7 plus x over 3 natural log of a half. Now let's go ahead and get rid of this fraction, x over 3. Let's turn it into just x. And the way we can do that is by multiplying everything by 3. So multiply by 3 on both sides of the equation, get 9x plus 6 is equal to 3 natural log of 7 plus x natural log of a half. Now we can move the x's to their own side and the constants to their own side. Let's move the x's to the left-hand side, so get 9x, then minus that x times natural log of a half is equal to 3 natural log of 7, then minus the 6 that was on the other side. And we can factor out an x here, take out that x, and we just have x times 9 minus natural log of a half is equal to that same right-hand side, 3 natural log of 7 minus 6. And finally, divide by that expression that's multiplying the x. So we get x is equal to 3 natural log of 7 minus 6 over 9 minus natural log of a half. And there we go. There is an exact solution. We can punch this into our calculator to approximate it, and we get that x is approximately negative 0.017. So now we know how to solve exponential equations with different bases, and in the future we'll also learn how to solve logarithmic equations.